So now I'll say linear differential equation. Linear first order and first degree differential equation. So it has a particular form, like this is dy by dx plus p of x into y equal to q of x. So if a differential equation is in this form, then this is the standard form of first order and first degree linear differential equation. So if differential equation is given in this way, then you have to find the integrating factor. Its integrating factor is e to the power integration of p of x dx. This is your p of x. Then your integrating factor is this one. Then what is its solution? Its solution is y into integrating factor. Y means this dy by dx means your y is the dependent variable and x is your independent variable. So this is the dependent variable into integrating factor equal to integration of q of x, this one, this is your q of x into integrating factor dx. X is your independent variable. So now go to a problem. Suppose a equation is given. Suppose this is given dy by dx plus 3x square y equal to 6x square. So now this is a first order first degree differential equation, because this is the derivative term, its order is 1, degree is 1, and this is coming under this linear differential equation, because this is in this form dy by dx. Here p of x is 3x square and your q of x is 6x square. So we can write this is a first order first degree first order and first degree linear differential equation. So here p of x is your 3x square and your q of x is 6x square. Then next is you have to find what is your integrating factor. So now integrating factor is e to the power integration of p of x dx. This is e to the power integration of p of x is your 3x square. So this is 3x square dx. Then what is the integration of 3x square? This is 3 into x cube by 3. So e to the power x cube. So integrating factor is this one. Then after finding integrating factor, its solution is y into integrating factor. So y into e to the power x cube. This thing is equal to integration of q of x into integrating factor dx. So q of x is 6x square, then e to the power x cube dx. So now I just solve this one. So take x cube equal to t. So if I will take x cube equal to t, then 3x square dx, this is your dt. Now I will substitute this thing here. That means this is your this is 2 taking common, not common, you can take 2 outside, then there will be 3x square. So 3x square and dx, this is your dt. Then you can write this is e to the power t into dt. So in place of x cube you will write t, and in place of 3x square dx, this is your dt. So this one can be written as 2 times e to the power t dt, its integration. So this is e to the power t is integration is e to the power t, then plus c, then this is 2 times e to the power t means this is e to the power x cube plus c. So y into e to the power x cube, this is your this one, or you can write this is y equal to e to the you can divide e to the power x cube on both sides. So this will be 2 into e to the power x cube, e to the power x cube can cancel out, then c into e to the power minus x cube, e to the power minus x cube. So this will be your answer. So this is the procedure, just you have to remember. So if this is your the linear differential equation is in this form, dy by dx plus p of x dy by dx plus p of x into y equal to q of x, then its integrating factor is e to the power integration of p of x dx, and its solution is y into integrating factor equal to integration of q of x into integrating factor into dx. This x is your independent variable and this y is your dependent variable. Similarly, if suppose this thing is given in this way, like in the reverse way, suppose this is in dx by dy, then this one will be your p of y into x equal to q of y. That means here x is the dependent variable, y is the independent variable. So here the integrating factor will be e to the power integration of p of y dy, and the solution will be here you wrote the independent. For this one you can write this is x into integrating factor equal to integration of q of y into integrating factor dy. That's the reverse of this thing. In place of x you have to write y, and in place of y you have to write x. So this is one solution. So if a initial value problem is given, like suppose another problem is given in this way, solve x square y dash plus xy equal to 1 and y of 1 is equal to 2, and here x is greater than 1. So here y of 1 equal to 2. So first try for this one. So x square y dash, you can divide x square on both sides. So x y dash plus this is 1 by xy, 1 by x square. This is dividing x square on both sides, dividing x square on both sides, and this y dash means this is your dy by dx plus 1 by x into y equal to 1 by x square. So now this is a linear form, which is in linear form. So what is your p of x now? Your p of x is 1 by x and your q of x is 1 by x square. So after knowing p of x and q of x, then you will find what is the integrating factor. Integrating factor is e to the power p of x into dx, that is e to the power 1 by x into dx, which is e to the power ln x. Then e and ln can cancel out, then it is your x only. Then what will be the solution? Solution is your y into integrating factor equal to integration of q of x into integrating factor into dx that means this is y into integrating factor is your x equal to integration of 1 by x square into integrating factor is x dx. So what is this one? This is integration of 1 by x dx. So this is your ln x plus c. So y into x is your this one. So y is your 1 by x whole into ln x plus c. So this is your y or y of x, that means y in terms of x. So y of x is your this one, and this is your initial value problem, that means its initial value is given y of x equal to 2 means that means when x is equal to 1 y is equal to 2. That means you have to put in place of x 1 and in place of y you will put 2. So I can write applying initial values we get, or put x is equal to 1 and y equal to 2. So y of x, or this is y will be 2, then in place of x we will put 1, so 1 by 1 into ln 1 plus c, and now ln1 is 0 or log 1 is 0, so the right hand side is only c and left hand side is 2, that means your c is equal to 2. So now putting c equal to 2 in equation 1, putting c equal to 2 in equation 1, we get y equal to 1 by x whole into ln x plus 2. This is your answer. So this is the linear differential equation. Now comes to Bernoulli's equation. So Bernoulli's equation, that means suppose a differential equation is in this way, like dy by dx plus p of x equal to y equal to q of x into y to the power n for n greater than equal to 2. So if a differential equation is in this form, then we will say this is a Bernoulli's equation or Bernoulli's differential equation for n greater than equal to 2. You know, if n is equal to 0, like y to the power 0, for n, suppose for n equal to 0, then what is this one? Dy by dx plus p of x into y equal to q of x, y to the power 0 means 1, and this is q of x, that means this is your linear differential equation. So for n is equal to 1, then this is your dy by dx plus p of x into y equal to q of x into y, because y to the power n means y to the power 1 in place of n equal to 1. So which is your dy by dx plus p of x plus minus p of x minus this is q of x into y equal to 0. So you can solve it in separation of variable wise. So that's why I am just omitting n equal to 1 and n equal to 0. So I am only considering for n equal to 2 or more than 2. So if n value is greater than equal to 2 and the equation is in this form, dy by dx plus p of x into y equal to q of x into y to the power n. So then that equation is in Bernoulli's equation form. So if a Bernoulli's equation form is given to you, then you will divide this thing, this y to the power n on both sides. So divide y to the power n on both sides. We get this is your dy by dx. I am dividing y to the power n, that means this is 1 by y to the power n into dy by dx plus p of x into 1 by y to the power y to the power 1 is here, and I am dividing y to the power n, so this will be y to the power 1 minus n, y to the power 1 minus n, this is y to the power 1 minus n equal to q to the power x. So after getting this thing, now or let y to the power 1 minus n equal to z. I am taking this thing as a variable z, another variable, this is z. Now taking the derivative of both sides with respect to y, then d by dx of y to the power 1 minus n equal to d by dx of z. So taking the derivative, this one is 1 minus n into y to the power 1 minus n minus 1, which is y to the power minus n into dy by dx, and this one is your dz by dx. And what is this one? This is 1 minus n, or you can take this thing to right hand side. So y to the power minus n means this is 1 by y to the power n into dy by dx, and I will divide this thing on right hand side, so this will be 1 divided by 1 minus n into dz by dx. So now after getting this thing, if I will put this thing here, because there is 1 by y to the power n into dy by dx, this is 1 by y to the power n into dy by dx. Suppose I will give this one as equation 2, and the given equation is equation 1. So now I will write equation 2 becomes in place of this one, I will write this one. This is 1 divided by 1 minus n dz by dx plus p of x into, this one is your z, y to the power 1 by n, this is your z, equal to q of x. So if I will multiply this one, that means multiply 1 minus n on both sides, this will be dz by dx plus p of x, this is 1 minus n into p of x z, p of x into z, this is your 1 minus n into q of x. Now this is a linear equation, which is a linear differential equation. That means the Bernoulli's equation is reduced to a linear equation. Now after the reduction, we can apply the formula for linear differential equation. First you will find the integrating factor, then you will write the solution. Now comes to a problem. Just writing a problem. Suppose the equation is given 6y dash minus 2y equal to xy4. So say this thing, this is 6 into dy by dx minus 2y equal to x into y to the power 4. Say the power of y is 4, which is greater than 2. That means we can say this, which is a Bernoulli's differential equation, which is a Bernoulli's equation or Bernoulli's differential equation. So now I will divide this y to the power n or this y to the power 4 on both sides. Now dividing, y to the power 4 on both sides, we get So y to the power 4 on both sides. So 6 divided by y to the power 4 into dy by dx minus 2 into this is y, then dividing y to the power 4, it will be 1 by y to the power 3, then this thing is your x. Now whatever the whole term y here, I will take that as z. See this one, after this term or after this p of x, whatever the y whole thing here, I am taking this thing as z. So I will take 1 by y cube as my z. I can take 1 by y cube, this thing equal to z. That means this is your y to the power minus 3 equal to z. Now taking the derivative of both sides with respect to x, so this will be minus 3 into y to the power minus 4 into dy by dx. This is your dz by dx. Then y to the power 4 into dy by dx. This is your 1 by minus 1 by 3 into dz by dx. So now equation 1 becomes, so this is 6 into 1 by y4 dy by dx. This is y to the power minus 4, 1 by y4 dy by dx. So I can add this thing as minus 1 by 3 dz by dx, then minus 2 into this is z, 1 by y cube, this is your z, equal to x. So now just simplify to line, this is 3, so cancel out, then dz by dx. Now this is minus 2, now I will divide minus 2 on both sides, so dz by dx minus z equal to plus z equal to x by minus 2. It means I am dividing minus 2 on both sides, so this one you will get, which is a linear equation, which is a linear differential equation. Now what is your p of x here? P of x, the coefficient of z is your p of x, because I have the linear form. This is dy by dx plus p of x into y equal to q of x, and here in place of y z is here. That means in place of y there is z. That means this is dz by dx plus p of x into z. So after removing this z, the only 1 will be left. So p of x is your 1, or the coefficient of z is 1 only, so p of x is 1, and q of x is your minus x by 2, minus x by 2. So this is your q of x. Now what will be your integrating factor? This is this is e to the power integration of p of x dx, which is your e to the power integration of 1 into dx. So e to the power x, this is your integrating factor. Then what will be solution? This is in dz by dx, your z is the dependent variable, so my solution is z into integrating factor equal to integration of q of x into integrating factor. Q of x is your minus x by 2 into integrating factor e to the power x dx. So what you will get? So what is the right hand side here? Taking minus half outside of the integration, then this is x into e to the power x dx. So what is the integration of this one? By Euler formula. This is the first one, this is the second one. So minus of taking outside, first into integration of second minus integration of derivative of first into integration of second dx, which is your minus half whole into x e to the power x minus e to the power x. So this is e to the power x or minus e to the power x by 2. That means e to the power x taking common, this is x minus 1 fall into this thing. So z will be your, now dividing e to the power x on both sides, this one is your, this one, now dividing it plus c, plus c. So your z will be, that means you get z into e to the power x is your minus half e to the power x whole into x minus 1 plus c. Now dividing z on, so dividing e to the power x on both sides. So what you will get, this is your minus half whole into x minus 1 plus c into e to the power minus x. So now remove z. We took z as, this one is your z, z is 1 by y cube. So in place of z I will write this is 1 by y cube is your minus half whole into x minus 1 plus c into e to the power x. So this is your solution. This is all about your Bernoulli's differential equation.